Hello everyone, it's my pleasure to introduce to you our work on an on-demand forklift hailing system for Intralogistics 4.0 applications that I've done together with my colleagues Matthias Breslein and Benedikt Elzer at the Dagendorf Institute of Technology. If we look back at the industrial evolution, we can see four major steps. The first one took place in around 1784 with the invention of the weaving chair, and this was the mechanization of work. So the mechanization was taken and sort of brought to the next level by building tools that help with the mechanically work-intensive steps. The second step was the electrification in the 1870s. One famous example for that is the manufacturing line that with the use of electricity could increase its speeds. The third step was the automatization, and this is not that long ago, so maybe around 50 years. We started using SPSS controllers, having sensors and actuators in our industrial production machines. And that helped a lot to improve the speed and quality of single machines. However, they are in this third industrial evolutionary step, they were still treated as silos, so single machines. And now in the fourth industrial evolution step, they are starting to become interconnected. This is shown here in a nice example. So one robot arm pours the beer while the other one holds the glass. And if you ever poured a Weissbier yourself, you know that this is not a trivial task because the foam tends to go over the top. So, but coming to our problem, so we didn't take care of pouring the beers here. We had the intralogistics problem, or we had a company that had an intralogistics problem, and they called us. They are producing injection molded plastic parts for the auto industry, and they said, hey, look, our process is as follows. We have this big production machines, and they produce these plastic parts, and then we stack them in a container like this. And when the container is full, somehow the forklift driver finds out that there's a full container waiting at some machine on the production shop floor, and takes the container and brings it to the warehouse, and in the warehouse it picks up a fresh empty container and brings it back to the machine so the operator can stack more fresh parts into that box. The problem with this approach is that the forklift drivers roam around on the shop floor, and this is an inefficiency that causes empty kilometers on the forklifts, empty mileage on the forklift, but also a loss of time. And forklift drivers are expensive, especially if you have 3 working shifts, so if you work all around the clock. So what's our proposed solution? Well, our solution was to transition from fixed assignments of forklift drivers to a more dynamic allocation of forklifts to machines. So at the moment in that facility, the forklift drivers took care of a few machines, and they had 5 forklift drivers, and our goal was to make this assignment of forklift drivers to machines more dynamic by employing such a forklift hailing system. And in the first step, we analyzed the process, and the process that we see from the forklift driver's point of view looks as follows. First, the forklift driver receives a new job. He then drives to the machine, picks up the full box. Then he goes to the storage facility, stores the full box, picks up an empty box, and delivers that empty box to the machine, and then the job is done and he can receive the next job. And so from a technical point of view, what we needed was machine operator touch points. So we needed some kind of means for the machine operator to hail a forklift. And we implemented 3 different touch points in this paper. So There is a smartphone app that you can use. There's a web app, because some of these machine operator workspaces, they had this big touchscreen monitors to show the current working order, for example. And the third system that we implemented, or the third touch point, was this embedded touch point, where we had a small embedded device that just basically had a button to call a forklift to that machine. Then, of course, we need some kind of server component that should be lightweight. That's why we chose a Raspberry Pi here. That receives all the requests from the different machine operators, and that then sort of hails the forklift, right? It notifies the forklift driver, hey, there's a new job for you. And not only should this server component take care of the communication aspect between forklift drivers and machine operators, but it also had to kind of perform the dispatching, right? So think about a cab dispatch center. So you would also need to figure out which forklift driver should take this new job request. And then lastly, we need the forklift driver touch point. Here we just developed one solution that was like a mobile phone app. And it turns out that mobile phones are a really good technical platform, because they come, they can deal with the rugged lifestyle of a forklift driver, so with all the vibrations and so on in the forklift. But also they come with a ton of wireless standards. They have a display, a touch screen. Everyone knows how to use them. And you can get all this great accessories. So the way we mounted it in a forklift was we just bought like this suction cup mount that you would use in a car to put your phone to the windscreen. And we mounted it to the windscreen of the forklift. And also the other nice thing is that for smartphones you can get this cigarette plug chargers. So for the cigarette lighting plug, the 12-volt plugs. And it turned out that also the forklifts had this kind of cigarette lighters. So we could easily plug our smartphone in for charging. And this was the view of the forklift driver. So when a new job arrived, the phone would give an audible alert, and it would also show a different screen that, hey, there's a new job, please drive to this machine and pick up the parcel. And then the forklift driver would say, okay, I did that. And then it would switch to the next screen and so on until the job is done. And it would also recommend the forklift driver where to unload the current parcel based on the previous history. From the machine operator point of view, it looks even simpler, because there's just basically a button to say, hey, I need a forklift. And this can either be done through this web client here or this small embedded client. And when the system registered the request, it would show like a waiting parcel icon here, so that the machine operators won't end up clicking like 5 times, even though there's only one box. So they get some visual feedback that their request was heard by the server and is being assigned. Also, we implemented a shift manager touchpoint in the form of a dashboard. So this is like an example shop floor, right? You have this 10 different storage facilities, and you have 4 production machines, and you have, for example, 1 forklift. And then as a shift manager, at any point in time, you could see what's going on the shop floor. So for example, you could see that one package is, or one box is waiting at machine 1. At machine 2, there's 2 boxes waiting. At 3, there's 2 boxes waiting. And at 4, there's 3 boxes waiting. This could help you to understand what bottlenecks are in your current production, and whether you should, for example, call an extra forklift, or whether you want to change some assignment. You could also group here machines and forklifts together, such that certain machines call only certain forklifts, or certain forklifts are only called by certain machines. So you could group them here, and you would see a log of all the open jobs and their current state and so on. Why do we think this is enabling Industry 4.0? Well, because with the data that you collect with such a system, you can enable descriptive analytics. So for example, you can build a dashboard where you can visualize the current forklift workload. You can visualize the plant productivity, because if no forklifts are called for a long period of time to a certain machine, you know that this machine has a problem because it's not producing as it should be. You can perform automatic reporting of machine interruptions and monitor machine productivity. So instead of having a dashboard, you can get a weekly report, for example. You can perform predictive analytics. So for example, you could predict forklift maintenance needs. You could predict machine interruptions and maintenance. And you could perform predictive workforce planning. So you could learn from certain production data how many people you need to efficiently handle that workload, to not have too many people on site, but also have enough people to deal with the workload. And lastly, you could switch out, for example, the scheduling algorithm of how the forklifts are being assigned, so the dispatching part of the system. And you could, for example, perform A/B testing and test out different scheduling and routing algorithms and test one against another. So you can do data-driven decision making with this as well. So we built a system and we tested it in our lab, of course, and then we brought it to the evaluation phase in that company. So we equipped 12 machines with such machine operator touch points and 2 forklifts with smartphones, and we tested for 14 days. In those 14 days, we recorded 690 jobs. And then we computed 2 timing types to evaluate the forklift performance. So from the time that the forklift was hailed, right? So the machine operator hails the forklift, the server queues the job, assigns the job to a forklift driver, and then the forklift driver receives the job and picks up the full box, right? We measured all that time between hailing the forklift and picking up the full box. This was the so-called pickup delay time, because then we know, okay, from the request of the machine operator, how long will it take until something happens, right? Until the box gets picked up. And we could then plot the results, so we can see how that pickup delay is distributed over time. So this is a cumulative histogram. And the same thing, the same analysis we did, but for the total round trip time. So from hailing the forklift to queuing the job, assigning the job, receiving it, picking up the box, storing, picking up the empty box, and delivering the empty box. So for the total round trip time, from creating the job until like completing the job, you could say. And if we plot those results, we get the total round trip time in minutes. And then what we can do with these graphs that was quite interesting to the management was we can do this kind of quality of service measures, that we could in the end say, okay, for 80% of all the jobs that we saw in our system, we recorded a round trip time of approximately 10 minutes or less. So the manager instantly understands from this, okay, 80% of all the jobs are done in less than 10 minutes. Yeah. And I think this is quite interesting if you're the manager of such a plant. So to conclude, we delivered an architecture blueprint for a forklift hailing system. Our system, supports optimized scheduling algorithms. So we just implemented simple FIFO, but in principle we support any arbitrary algorithm, and it adds value to all parties. So for the machine operator, it means that there's a faster pickup and deposit of deliveries. For the forklift driver, there's a higher utilization. For the shift manager, we allow insights and flexible resource allocation using the dashboard. And the management, of course, gets some key performance indicators that they can use to optimize the plant. throughput and efficiency overall. So thank you very much.